All right, so let's take a look here at this problem. We have a polynomial function. We want to answer these various questions about the properties of the graph. Um, let's see if this is in standard form. 5, 4, 3, 2, 1, constant, so that the exponents are in descending order. There's no missing terms. The degree of this polynomial is the largest exponent here on a variable, which is 5. 5 is an odd number. And the leading coefficient is the number that's in front of this x to the fifth, which is 20. And 20 is a positive number. So we know what the end behavior is going to be when this graph is far away from the origin, far away as you approach x equals positive infinity. It's going to be going up to the right, and as you approach negative infinity, as you move to the left, you need to be going down on the graph. So that's this choice too. All right, so let's come over and see if we can factor this. Oh, wait, to determine the y-intercept, we let x be 0. All of these terms are 0 except this constant term. So there's the y-intercept, which has coordinates 0, negative 32. So it's down here somewhere. All right, so to find the x-intercepts, we want to set this polynomial function equal to 0. And we want to solve this equation. But this equation is pretty difficult to solve. We do not have any kind of technique like an x method or any kind of a closed formula that will, when it's a quadratic, we can use a quadratic formula. And although, I don't even have it memorized. There is a formula for an x to the third power as well. But there's not one for x to the fifth. All right, so each of these zeros has a multiplicity of 1, so we can do synthetic division on these things only once. So let's do it. It doesn't matter which one we do first, so I'm just going to do 4 first. Now we're expecting to get a 0 remainder. If we don't, then I suppose I would check to make sure I've copied this down correctly from up above, and then check my arithmetic to make sure I haven't made, like sign errors and stuff like that. So let's hope that doesn't happen. Probably should be checking this on a calculator because I'm not the best at arithmetic. So we do get a 0, so that's good. So now let's come down and do it with 1. And we should get a 0 here as well. And we do. So let's do it now with -2. And we should get a 0 here as well. Let's see if we do. And we do. All right. So what does that give us then? Well, let's write it over here. So this guy now, we factored it enough to know that it's x minus 4 to the first, x minus 1 to the first, x plus 2 to the first, and then this 20x squared plus 11x minus 4. I'm going to erase all of this just so I can have some room to do my x method, because now that we've got it down to a quadratic, we know how to factor this last factor here. So let's place an x. Our middle term is 11x. Our first term times our last term is negative 80x squared. So this is probably 16 times -5, right? Let's double check that. Yeah. All right, so since the leading coefficient is not 1, let's continue, whether you want to call it a table or a chart. I don't know what you guys call it, but along one diagonal, let's put the first term and the last term, and then from our x, we've got 16x and minus 5x. So 4 is a common factor here, and -1 is the only thing, the negative sign is the thing that's common there. A 5x is common here, and a 4x is common vertically there. So that means that we can come in, and we know that this polynomial, now that we have, we can factor it completely. We've got x minus 4, x minus 1, x plus 2, and all of those have a multiplicity of 1, and these guys also have a multiplicity of 1, the 5x plus 4 and 4x minus 1. So if you set 5x plus 4 equal to 0 and solve, you'll subtract 4 and divide by 5. And if you set 4x minus 1 equal to 0, you'll add 1 and divide by 4 to solve that. So all of these, since they all have a multiplicity of 1, and that's an odd number, it's crossing. We don't have any touch and turns. All right, so let's return back up here to this end behavior and see if we can draw this sketch with a little bit more detail. because we know that these 2 points are connected in a smooth and continuous fashion. So we only have 2 negative x-intercepts, and we have 3 positive x-intercepts. All right, so we know at this one that's the smallest, the -2, that this is crossing through it. We don't know how high it's going up. We don't know how symmetrical it is when it turns. We know it's going to come down to -32 for the y-intercept. We don't know exactly how, if it's going to come down and then be crossing through on the way up, or if it kind of does. We don't have a similar touch and turn type. Well, we know it crosses. It always crosses the y-intercept. It'll never do a touch and a turn because then it would fail the vertical line test. But I don't really know the steepness. I really don't know how it's approaching that y-intercept. So we know this is crossing. We don't know how it's turning, but eventually it will. This is crossing. We don't know how it's turning, and this is crossing. So even though I've drawn these at the same height, we have no idea if that's really going to be the case or not. So let's look at our choices then and see what we've got. I think I have this pulled up. Yeah, all right. So number 1's not it because the end behavior is up and up, and ours is down and up. This guy in number 2, it could be it because we have a down and up, and 1, 2, 3, 4. We've got 5 x-intercepts. 2 of them are negative, 3 of them are positive. They're all crosses. So this is definitely a candidate. Here it's going up to the left. Ours is going down, so it can't be that. And it can't be, for the same reason, it can't be this one. It's got the wrong end behavior. It's going up. So it has to be, this number 2 has to be our choice among these 4. It's what we're expecting. And if we look at the numbers, the -2, what was it? -1/4. No, -4/5. So -2, something real close to -1. And then 1. We've got a 1/4. Yeah, a 1/4, a 1, and a 4. Yes, it's definitely choice 2. All right. I hope that helps, and I'll talk to you later. Bye.